Okay, this is the homework help video for division property of exponents. It's Monday night's homework. That is if we are still in the year 2015. If it's a year after, then it probably is a different night homework. Number 1 is 5 to the 8th power over 5 to the 6th power. And we know that 5 to the 8th is the same as writing 8 fives. 8 fives multiplied by each other. 1, 2, 3, 4, 5, 6, 7, 8. And 5 to the 6th is the same as writing 6 fives multiplied by each other. So 1, 2, 3, 4, 5, 6. I can just do some cancellation. I'll use a different color here. So 1 for 1, 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 1 for 1. End up with these two fives, which is equal to 5 to the 2. And that, of course, is equal to 25. But a simpler way would be to subtract the exponent in the denominator from the exponent in the numerator. Because I know that as many of these exponents I have on the bottom, that's how many I'm subtracting from the top. And that's what I will end up with in my numerator. So I've essentially solved what will be in my numerator here, if you look at it like that. So 8 minus 6 is equal to 2. Therefore, my fraction will be the fraction, or the base, which is 5 to the 2. That's where that comes from. So number 2 is 15 times x to the 6th divided by 5 times x to the 6th. Already, what I know with my subtraction of exponents, I know that I can subtract 6 minus 6 and it equals, and it equals 0. I'm making a video. And it equals 0, which is going to be x to the 0. Can you hang on just 1 second? So I prove it over here when I write 3 times 5 times x times x times x times x times x times x over 5 and then 6 more x's. I can cancel all these out, sort of boring after a while, but sure, I could do it like that. And then I could write my 15 as 3 times 5, and I know that I end up with just this 3 on top, so my answer is 3. That works the same here. I end up with 15 over 5 x to the 0. Well, x to the 0 is just 1. And 15 over 5 times 1 is equal to 15 over 5. 15 divided by 5 is what? Annika, what is 15 divided by 5?
3.
It's 3. I have a special visitor right now. Okay, and I'm just going to keep going because I got to finish this really quick. Okay, this one gets a little trickier. Number 4 is a to the 3rd over all this business here, and then all within parentheses squared. So this guy here tells me that I have 2 of these sets. So you can see that I've written a to the 3rd b times a to the 3rd b. I'm going to solve everything inside this parentheses before I deal with this exponent here. So this is essentially, I'm going to cancel 1 for 1 here because this is the same as a to the 3rd over a to the 3rd times b times a to the 3rd times b. I could combine these two and make it 6 and then subtract, but I might as well just go bam, bam. That's a 1. Then I have 1 over a to the 3rd, b to the 2nd, because I have 2 b's, 1, 2. All squared. Did you do this already?
Yes.
Yeah. And then that's 1 to the 2nd power. And then this again, a to the 3rd, b to the 2nd power. So I have another step I'm going to do. 1 to the 2 times a to the 3 times b to the 2. And both of these are multiplied by 2. So I'm going to call this 1 on top. And that's a to the 6th, b to the 4th. And we're finally done with that. My last one here is, it's going to be a long video, is I'm going to deal with each of these exponents separately. So when I have a quotient, when I have quotient exponents, I can subtract the bottom from the top, or subtract my denominator from my numerator's exponents. So 8 minus 9, let me set myself up actually like this. I'll use pink. So my x's are 8 minus 9. What is 8 minus 9?
Negative 1.
It's negative 1, right? So negative 1, and then for my y's, I have 4 minus 2. 4 minus 2. Oh, excuse, why did I get a 2? Seriously, I'm hallucinating. Okay, 4 minus 1, because there's nothing there, so it automatically used to mess a 1. 4 minus 1 is what?
3.
And then z's, I only have one on the bottom, so I don't have any problem I need to do. So these are the exponents of my numerator. So I have x to the negative 1, y to the 3 in my numerator, all over z. And then with this negative exponent, it's really a southwest plane ticket to the other side of the division line. Did you know that? That's what a negative exponent does to x, z. And we are done.